Hi everyone, and as you can tell, welcome to another video to teach you about the parent function from section 1.3 of our class. And so today I'm going to show you how to do that. Hopefully you find this enjoyable. One more time, feel free to pause the video or speed it up just in case you need me to go slower or you need to go faster, just so we can pick up on our lesson. Hopefully also you received one of the handouts from the supply teacher, and we're going to take a look at that. So we're kind of changing up the gears for today's lesson. Yes, we're going to now reinforce domain and range, but we're going to add on functions, which again, for every x, there's only one y, some function that you need to be aware of. So in order to explore this today, we're going to generate by using a table of values, graph them, and observe some major characteristics. I do apologize in advance. Again, if I'm jarring here, I'm going to switch over to sharing my screen to this Word document. I'm going to cover my screen, my camera if that's all right. And so as you can tell, what we're going to try to do, there are several parent functions that we're going to look at, and we're going to practice graphing them. Feel free to pause the video whenever you need to and try it yourself. At any time, also, I will give you the answers on what you're supposed to do. Also, try to make sure you can grasp what we're talking about by key points, and it'll make sense when we look at the handout. And last but not least, once we see the visualization of our functions, we'll ask this domain and range. So take a moment, looking at our handout. Hopefully this is the first one you see. Using a table of values, we're going to plot the following functions. Now we'll answer the second question as soon as we get it done. Let me just remove my keyboard so I actually can do this with you. And you might need a calculator for one of our functions. Also take a moment to construct your graph or your grid. Remember, we always have a labeled axis. That's our x, that's our y. For this video, I'm just going to ignore it to speed up our lesson. Also, what I am going to make sure you understand, each value on our grid represents one unit. So I'm just going to do this once. And hopefully everyone can see that. So for our first graph, let's title this, we have y equals x. This is known as the linear graph. You know this is linear because the degree of the exponent of the variable is 1. So don't feel bad if you don't know what this line is, but you have seen it from our earlier video on Thursday. Let's try to choose some numbers. I'm going to try maybe -3, -2, -1, 0, 1, and 2. I left more space so that you can try it. One more time, just like in grade 9 and grade 10, we try to choose values that are around the origin. So don't get me wrong, you could try 21, 22, 23. And so, using the formula y equals x, really easy. I'm going to do this off to the side. This one's super easy. What are the y values? Well, it's super easy. For the first one, when y equals x, and if we plug in the value of -3, that answer is -3. This one's super easy. You keep on going, you get -2, -1, 0, 1, 2. Let's plot these key points. Pause the video if you want to try it yourself. Where's -3? -3? It's right there. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Because we want to know the whole function, because x belongs to all real numbers. Technically, we can actually join these key points. And I screwed up near the end. But this is the y equals x line. It's a straight line. We'll come back to the end with the domain and range. But notice one key feature. This is direct variation, or it goes to the origin of 0, 0. Let's keep on going. Y equals x squared. You should all know what this is from grade 10. In grade 10, this was known as the quadratic. This is the parent function or base function. Pause the video if you want to try it yourself. But what we're going to do is graph this quadratic. Again, I'm going to use -2, -1, 0, 1, 2. And doing some basic math, I'll choose a different color. Hopefully it doesn't be nicer. We'll use green. We want to do y equals x squared, for y equals -2 all squared. We get y equals 4. So -2, 4 is the key point. Try it yourself right now. Finish off the table of values. And I think you're understanding that this is the 5 key points for quadratics. We're going to get 1, 0, 1, and 4. Plotting these points, we get -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. I can do my best. Notice our end behavior here. This is clearly a parabola. One more time, what's a key feature? And again, like I said, we'll do at the end. What are the domain and range? 0, 0 is the key point. You also know this as the vertex. It's also known as the root. It's also known as the y-intercept. Just some extra characteristics that you could describe for yourself. The main stage is to recognize that we have this kind of curved shape. It's technically not a U. That is why it's called a parabola. Now, for enrichment purposes, I'm not really supposed to teach you this y equals x cubed. So I'm just going to do this one really quickly. Y equals x cubed is known as a cubic. I don't know why it still stayed red there, but that's okay. Again, I'm going to do this one really quickly. I'm not going to talk too much about this because I'm actually technically not allowed to show you this. But if we do y equals x cubed and you plug it into the function, what do we get? We get -8. -8, -1, 0, 1, 8, 27. What is this going to look like? It's going to look skewed, and hopefully I can fit this in. That's -2, -8. That's -1, 1, 0, 0, 1, 1, and 2, 8. Some of you might actually see this picture in our classroom. It's the dance moves that you see on the board near the smartboard. But again, notice what's kind of neat. This funny kind of S-like shape. It's kind of like a squiggle. Just to make sure we're all clear. You don't really have to worry about the cubic, but I would like you to know it. It'll empower you, especially if you decide to take advanced functions next year. Let's keep on going. The new ones now. Pause the video if you want to try it yourself. This is y equals root x. This is called the root function, or also known as the radical function. Notice for this one, I actually skewed it, and the reason why I just want to make sure I have enough room. This one's interesting. I'm still going to set this up as -2, -1, 0, 1, 2. But some of you already are going to understand what I'm going to be doing. I'm going to put 4 and 9. Now, believe it or not, when you punch this into the calculator, and let's try it to show my work, y equals the square root of x, and plugging in the -2, what are we going to get? Not an answer. You get a math error. So there's no answer for y. So that seems strange, but let's keep on going. Plug in -1, no answer. But this is why when I was talking about on Wednesday's class, the square root of 0, and just to check my work, to check square root of 0, that is actually an answer. So 0 is the output when you input x is 0, y is 0. How about the square root of 1? The square root of 1 is 1. Now the square root of 2, it does exist. And even I don't memorize my thing. My calculator just died on me. Oh my gosh. So the square root of 2 when you use your calculator is an irrational number, 1.414. So it doesn't exist. So it exists, but it's not easy to plot. But now you understand the square root of 4. Is 2. The square root of 9 is 3. So if you've been listening about key points, the key points are as follows: 0, 0, 1, 1, 4, 2, 9, 3. Keep in mind, if you ever forget this, you can always generate the table of values. Pause the video if you want to try it yourself. Let's plot these key points. So 0, 0 is a key point, 1, 1 is a key point, and although 2, 1.414 keeps on going, I'm not going to plot that. One more time, when we try to graph, we don't really try on a graph in the spaces. We want to graph on the grid. So where's 4, 2? 4, 2 is there. And the last one, 9, 3, is right over there. And notice it keeps on rising. And this is what the root function looks like. One more time. Notice 0, 0 seems to be a key point. So this is a root function. At the end, after we do all these parent functions or base functions, I'll give you kind of a sample question if you want to try to test yourself to recognize. And that's what we're looking for. Can you recognize these extra functions? Let's keep on going to the next one. Now this one is the new one. The way that you read this is the absolute function. And this is for sure is new in grade 11. Don't be embarrassed. You don't know really what this new mathematical symbols are, but those two vertical lines do not represent parallel. It represents, believe it or not, the magnitude of the distance from 0. However, a lot of students will find it easier to understand it. You can simply make it, the answer must be expressed as a positive result. This one's going to be weird. So let me just show you an example. Don't get me wrong, we're not going to ask you any further questions. If I wanted to evaluate this math, didn't spell evaluate right? Evaluate. Oops. So this is read as the absolute of 4 minus 6. So just like in brackets, you do the in the absolute values, the 4 minus 6. 4 minus 6 is -2. But again, one more time, absolute means to make positive. So this answer is just 2. You're probably going to learn more about this in university. We used to teach it more in advanced functions. I think it has been removed, but this is a requirement for you to recognize this particular function. Pause the video if you want to try it yourself. But let's go to the table of values. And notice I'm still using -2, -1, 0, 1, 2. You can go further if you want. I'm just using those. So notice what we're going to be doing. I'll use blue. For the first one, y equals the absolute value of -2. What does that really mean? Well, the answer is going to be just 2. Keep on going. The absolute value of -1, well, that's going to be just 1. Absolute value of 0, believe it or not, is 0. Absolute value of 1, since it's already positive, it's 1. Absolute value of 2, it's just 2. So some of you are going to notice that when we plot these key points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And if you're still weren't too sure, plug in 3, you get 3. Plug in -3, we still get 3. I apologize, I'm moving above. So notice what we get. I should be using a ruler. I don't have a ruler on me. What shape does this look like? It looks like the letter V. So this is the V shape. Notice some similar characteristics. 0, 0 seems to be a key, kind of a vertex, and it's very sharp. So there's some similarities to a previous function that you looked at. Our final function, which is the trickiest one, which I tend to do last. And I actually made sure I had a lot of room. This is y equals 1 over x. This is known as the reciprocal function. I don't know why my R still stayed red. Let's change that. Reciprocal. Now for this one, I am actually going to put the scale out. And the reason why is because I want you to see it properly. That's 1. That's 2. That's 3. That's 4. So each square is actually 0.5. Take a moment again if you want to try it yourself. I like going in this detail so you can actually see what I'm doing. Now for this one, watch what I'm going to choose. For x, I'm going to start with -4, then -2, then -1, then -0.5, then 0, then 0.5, then 2. Oops, I forgot 1, Mr. Chen. 1, 2, and 4. So just like we were practicing with our functions, use purple. The first one we're going to do is y equals 1 over x. And for the x value that we're going to input, we're going to plug in y equals 1 over -4. And this answer is -1/4 or -0.5. Negative 0.25. It's been a long day. So that's what we get for y. If we plug in y equals -2, get -0.5 or -0.5. Plug in -1, you get -1. If you plug in -0.5 in this equation, check it yourself with the calculator. What do we get? We get -2. Now let's pause for a second. Unlike the other ones, I just generated the table of values first and then plotted it afterwards. For this one, the -4, I'm just trying to show you. Notice this number is not that bad. It doesn't fit on our grid, so we won't probably plot it. But the next 3 are probably nice key points. So let's plot them. So -2 and -0.5 is right over here. -1, 1 is right there. -0.5 and -2 is right here. Notice these are 3 key points. And I made 3 check marks so you could see them. Now what happens if we get y equals 1 over 0? Well, you already learned from grade 9 that when we divide by 0, this is called undefined. So we don't have an answer for that. So something seems weird. But let's keep on going. We're at 0.5 now. So y equals 1 over 0.5. And if you want to pause the video, hopefully you're going to see a neat pattern. But what do we get? We get 2. Plug in this one now. We get 1. Plug in this. We get 0.5. Plug in this. We get 0.25. Please, please, please don't memorize this. Rather, try to recognize a pattern or a trend. Pause the video if you want to see it yourself. Notice these 3 are nice key points. Let's plot those out. 0.5 and 2, that's up there. 1, 1 is right there. and 2 comma 0.5, that's right there. Now this one's going to be hard because this one, out of all the functions, has some characteristics which are weird. From left to right, notice it doesn't seem to cross the x-axis. And it looks like I'm drawing 2 lines. Physically, I am. But if I go from left to right, notice the end behavior goes more and more towards negative infinity on the y-axis. If you're understanding what I just did, I plotted all the functions from -4 all the way down to -0.5. Now at 0, there's no real value. So I cannot plot a point. I have to lift my purple pen and then continue onwards. And if we continue onwards, notice we get to this part. This is the function of the reciprocal. It has 2 characteristics, and the 2 characteristics are as follows. I'm going to try to emphasize them both with different colors. I'm going to use, hopefully, this orange to represent something. This function actually has what's called a vertical asymptote. And it happens to be at literally x equals 0. VA for short. And its equation is x equals 0. It's a vertical asymptote. Notice we cannot cross it. It causes the function to get closer and closer to it. There is another feature that's causing it. And I'm going to try to use a different color. I'll use this nice blue. Maybe not blue. Maybe we'll use the blue. And we have a horizontal asymptote. This horizontal asymptote is y equals 0. What's interesting about the horizontal asymptote and the vertical asymptote, I think you understand they're intersecting somewhere. And although 0, 0 is not on the function, it is the intersection point of those asymptotes. Short form for horizontal asymptote is HA. Let's scroll back and talk about now some features. So the linear function, the domain is x belongs to real numbers. The range for this parent function is y belongs to real numbers. Notice it goes in quadrant 1 and quadrant 3. If you were to talk about geometry, it makes a 45-degree angle. For the quadratic, notice the domain for this. All quadratics are x belongs to all real numbers. What is the range? Well, y belongs to all real numbers such that y is greater or equal to 0. It clearly opens up. The cubic, we're going to ignore, but x belongs to real numbers. Y belongs to real numbers. And if you just pause the video for a second and you think about it, notice the cubic has the same domain and range as the linear one. It has looked like it has a squiggle. One more time to repeat, you don't have to worry about the cubic. I just love teaching it. The root function, it's the one that's different from the ones that you just saw. It has a definite start. Where does that start at? 0, 0, and it goes towards the right. For this one, I'm going to use a different color to emphasize it. I'm going to use hopefully this purple or fuchsia. I'm going to write on the grid. I apologize because I wrote some stuff already. So the domain for this, x belongs to real numbers such that x is greater than or equal to 0. How about the range? The same one. Y belongs to real numbers such that y is greater than or equal to 0. Notice I used filled in dots to include 0. Root functions always has a definite start. Second last one, absolute value. This one has the same domain and range as the quadratic. X belongs to real numbers. Range is y belongs to real numbers such that y is greater than or equal to 0. Last but not least, the asymptote. And I'm going to just zoom out so people can see a bit better. The reciprocal function is this one. The domain happens to be x belongs to real numbers. And yes, there's a break. Where is the break along the x-axis? It seems to be right at 0. It does not exist. So it's every value except 0. How about the range? Same idea. Y is not equal to 0 for this one. Please make note of the connections here. The domain and range shows us where the function is going to lie. And at 0, it doesn't exist. However, the asymptotes, you can kind of think of it causing the function to get closer and closer to those horizontal and vertical lines. They'll just never touch it. In grade 12, you'll learn more about crossing asymptotes. But the only way to get from left to right or from the bottom top is to lift up the pen. Now, if you want to pause the video to surprise yourself, I am going to draw, and I try to use black. I'm just going to draw the sketches. These are quick. I'm just making this up really fast. And can you recognize what they all are? I'm only going to do 5 of them because technically you only need to know 5. The cubic will never be given to you. So if you just give me a moment, I'm going to draw them. Obviously, I didn't have this prepared already. The main thing is, can you recognize what these functions are? And we would like you to. And I should have used a different color. Let's try to match them. Pause the video if you want to try it yourself. Maybe work with a friend. Here's the answers. You should know the names, and you should know the equations. That is why you need to know these 5 parent functions. This is y equals root x, and it is clearly the root function. This is y equals absolute x, and it's the absolute function. This is y equals x. This is the linear function. This is y equals x squared, and it's the quadratic function. And this is y equals 1 over x, and this is the reciprocal function. So there you have it. Feel free to try to explore this yourself on Desmos. Please also refer to section 1.3 in your textbook. So hopefully this video made sense. And again, as always, feel free to read 1.3, fill in the work, help each other out, and try to explore it. You can always look at Desmos or GeoGebra, plug in the equations. And if you want to learn more, you can actually try to explore maybe what's a quartic, or y equals x to the 4, or y equals x to the 5. But obviously those higher degree polynomials, you'll explore that in advanced functions. Again, I want to thank you for watching this video, and hopefully you found it useful. Thanks for watching.